So this is the last of the set of standards for grade 6. We're going to end with statistics and probability. Here we have a list of those integral parts of statistics that we need to cover. Most of it is identifying what is a good statistical question, and then further how to represent that data using number lines, dot plots, histograms, and box plots, which some of you may be familiar with box and whisker plots. So we need to determine what are good statistical questions. A statistical question is one that can be answered by collecting data where there will be a variability in that data. Take a moment, write down your guesses. Which of the following are statistical questions? Pause the video, make your best guess, and then we'll go through them. How many days are there in March? This is not a statistical question because we can simply count the number of days and it will always be the same for March. How old is your dog? This is again not a statistical question because you're answering with a single number. However, when you look at how old the dogs are that live on the street, this is gathering multiple sets of data. So this is a statistical question. What proportion of the students at your school like watermelons? Again, a good statistical question because you're collecting data pieces. However, do you like watermelons is yes or no question. So no, because you're only getting a single data point. How many bricks are on this wall? That would not be a good one because you're only talking about one particular wall. If we asked a question like how many bricks are on a set of walls, then we could use that as data. What was the temperature at noon today at City Hall? This is also not a good piece of data as you're getting one single number at one point in time. One way to use a statistical graph is to visually represent a data set's shape, center, and spread. Tyler asked his classmates, how many times do you go to the movies each month? Then he recorded their responses in a dot plot. How could he describe the shape, center, and spread? When we talk about the shape, we have the following. Is it normal? Is it skewed left where there are more dots on the left? Or is it skewed right where there are less dots on the right? So I see this one as skewed right because there are less dots on the right-hand side and things kind of tend to stay on the left. When we talk about the center, we want to know where most of the data is clustered together. So I would say around 2 or between 1 and 3, most of the data is centered. When we talk about spread, we want to know how varied the data points are. Most of Tyler's data is spread from 0 to 5. And since 9 or 10 are far from the other pieces of data, we call these outliers. Describe the center, spread, and shape of the graph below. How many pencils do you lose each week? Center, most of the data is around 3 to 7 pencils. The spread, the cluster is from 1 to 9, and I see there are no outliers. I feel that the shape data is symmetric, so it's a normal distribution. It is not skewed one way or the other. The average recorded amount of water in cups that the cat Oreo drinks per week every day is as follows: 3, 3, 4, 5, 4, 4, 6. There are 3 types of averages: mean, median, and mode. To find the mean, we add all of our data up and divide by how many data points there are. So I add 3 plus 3 plus 4 plus 5 plus 4 plus 4 plus 6 divided by 7. So I get 29 divided by 7, which is about 4.14. To get the median, what we have to do is first order our data from smallest to greatest. The median is the one that's directly in the middle. So to find it, we start taking and crossing off one piece of data from either side until we get to the middle. So I see our median is 4. The mode is the one that occurs the most. So I see 4 is the one that occurs the most. The central tendency of a data set can be described using on these measures. Ashley wrote down how much money she found in her pockets every time she did laundry. Find the measures of central tendency for her data set. Take a moment to pause the video and we'll come together. To find the mean, we add all of our pieces together. So 10 plus 2 plus 2 plus 0 plus 0 plus 0 divided by 6, because there are 6 pieces of data, gives us 14 divided by 6, which gives us about 2.33. Again, the median, we start on the outside and we work our way in. Now this time I have 2 different pieces of data in the middle, so we'll find the average of those 2 pieces. So 2 plus 0 is 2, and 2 divided by the 2 is itself 1. And 0 happens the most often. Mrs. Turner scored all of the math quizzes. She decided to give everyone 5 extra points and recalculated the mean, median, and mode. Which of the following would happen? Would the mode stay the same? Would the median increase by 5? The mean would decrease by 5, or the shape of the data set would change? Well, the mode wouldn't change because all we would do would be adding 5 to each number. So by adding 5 to each number, it's still the same data, just multiplied by a factor of 5. The median would also increase by 5 because the numbers would just shift, but we're not changing how many numbers that we actually have. And finally, the mean would decrease by 5 is not true, and neither of the shape would stay the same. A student is 54 inches tall. How does she fit into the data as a class? Here are her classmates' information. Let's compare the mean. So the mean is we have to add all of our data pieces together. So I have 46 plus 50 plus 54 plus 54 plus 54, since there are 3 of them, plus 55 plus 55 plus 55 plus 55 for 4 of those, plus 56 and 56, 58 and 61. Dividing that by 13 pieces of data, we get about 54.5. The median of the data is 55, and we can get that by crossing off 1 piece of data from each side. I get to the end here and I have 3 55s, therefore the median must be 55. The mode of the data, the one that happens the most, is also 55. So when I compare the student's 54-inch height to all of my data points, I see that the student is shorter than the mean, the median, and the mode. Students always come to the principal's office and say that teachers never tell them they are doing anything wrong before giving out detentions, which is a true statement that the principal could say to change the student's mind. It looks like all of our options are talking about in mean, median, and mode. So let's go ahead and find the mean, median, and mode before we can identify which is the correct statement. So the mean, I have, of the number of warnings, there are 2 that are 1. There are 10 2 warnings. I have 12 3 warnings. And I have 6 4 warnings. So instead of saying 1 plus 1 plus 2 plus 2 plus 2 plus 2 plus 2, etc., I kind of use our properties of multiplication and what multiplication means to simplify. I therefore get about 2.73 for the number of warnings students receive before they get into detention. The median is the middle. So again, I went and crossed off. I ended up with a bunch here in the 3s left, so 3 would be the median. And then the one that happens the most is the mode, so the one that happens the most is 3. Now we can go back and look at our options that we have, A, B, C, and D. The amount of teacher warnings is almost 8 times. Well, the mean is not 8 times, so that's not true. The median and mode of the numbers of the teacher's warnings is 6 times. Well, mean, median, and mode is not 6. The mean amount of warnings is 2 times. Still not quite correct. The median and mode of the number of teacher warnings is 3. That is our correct answer. A pet store has the following numbers of fish in 7 different aquariums: 6, 12, 7, 5, 11, 6, and 9. Compare the mean, median, mode, and range of the fish in the aquarium. The pet store owner doesn't want any aquarium to have too many more fish than another. Which data measure would he be interested in? Use the grid to sketch the number of fish in each aquarium using a separate row for each. So I'm going to list my data here, and then I'm going to fill in how many, and I use different colors for a moment here. So our first aquarium has 5, then the next two have 6, then 7, 9, 11, and 12. What is the mode of the data? Which is the one that happens most frequently? That would be 6. 6 happens twice here. What is the median of the data? Again, we can either cross off bars or cross off here until we get one single number, or have to find the average of the two middle numbers. So we get 7. What is the range of the data? And range is the largest minus the smallest, so 7 is our range. Resketch the amount of fish in each row so that each row has an equal number of fish. So I'm going to start borrowing from these heavier sided pieces and bringing them down to start filling and see if I can't make these all equivalent in size. So I took a few from the red and the purple and brought them down, and I'm just kind of moving pieces around so that I create an equivalent set of data. Each row now has 8 fish. Let's see how that compares to the mean. So to calculate the mean, we add all of our data, divide by how many they are, and I also get 8. So 8 is the process, and by moving our pieces around is the process of making them all even. How can we calculate the mean absolute deviation? Flower florists collected data on the length of time in days their flower lasts before wilting. What is the mean absolute deviation of this data set? So I have our data points. We need to know what the mean is in general. So I calculate the mean, and I see that that is 10.5. In my table then, I will take my data point and subtract the mean. And I'll do this all the way down here. And then I'm going to take that mean and identify the absolute value of that mean. Remember, the absolute value is the distance away from 0. So all of my negatives go away. So here I've put the absolute value of my data. The next part in finding the mean absolute deviation is to actually find the average of the absolute values. So I add them all up together, and I still divide by 6 because there's 6 data points and we get 1. Since the 1 is a pretty small number, we can say that this data set has numbers that are pretty close to the mean. The standard deviation is the spread of how far away each data point is from the mean. Andy ordered 7 games from the internet. He recorded the number of days it took each package to arrive in the data set below. Identify and interpret the mean absolute value. So there's my data points. We need to find the mean, which is about 10.5. I take each data point and subtract 10.5 and get a bunch of data. And then I take the absolute value of all of those datas. I now need to find the mean of all of our absolute values. Notice we're still dividing by 7 because it is still 7 sets of data. I see this time it's about 4.9. Since the mean absolute value is larger, it can be said that the data points are spread further apart from the mean. We can look at measures of variation, which describes the spread of our data set. One way that we can measure variation is utilizing the range and interquartile range.
Ashley used a stopwatch to determine how quickly she could enter the combination to open her locker, and she recorded the data below: 40, 45, 75, 50, 50, and 95. In order to determine the range and interquartile range, we'll also need to make sure that our data points are listed from the least amount to the greatest amount. So I'm going to rearrange them, going from 40, 45 to our double 50s, 75, and 95. We can now identify our range by taking our largest minus our smallest. So we see our range is 55 seconds. And before we can find the interquartile range, we need to find a key set of our 5 numbers to determine that. We need the minimum, then the maximum, which is 40 and 95. We need to know what the median is. Our median we have 6 data points, so we take our middle 2 numbers, add them, and divide by 2, so we find the average of them, which is 50. We also need our first quartile, which is the first half of the data, the middle, which is 45, and our third quartile, which is the middle of the second half, and the middle of our second half is 75. Now we have all the data points that we need in order to find the interquartile range. But before we do that, this tells us that we have 100% of our data broken into 4 parts. 25% of our data lies between the minimum and the first quartile. 25% of our data lies between the first quartile and the median. 25% of our data points lie between the median and third quartile. And 25% of our data lies between the third quartile and the maximum value. We can now find our interquartile range by taking our third quartile and subtracting our first quartile. So 75 minus 40 is 30.
Doug recorded the grams of sugar in each of his favorite sodas. Describe the variation of his data set using range and interquartile range. So we know we need the minimum, the first quartile, the median, quartile 3, and the maximum. Putting our data set in order, I see that the minimum is 62 and the maximum is 120. Subtracting the 2 gives me a range of 58. The median is the middle numbers. So I look at 66 and 70 and need to divide by 2 to find their average for the median to be 68. The first quartile is looking at the first half of the data and finding the median of the first half, which we can see is 65. The quartile 3 is the second half of the data, finding the median of that, which is 78. Finding the interquartile range, taking 78 minus 65 to get 13. Ricky thinks that since the mean amount of money spent on snacks is greater than the mean amount of money spent on lunch, the mean absolute deviation of the amount of money spent on snacks will be greater. Is she correct? Explain why or why not. So I took a moment to kind of write down all of the sentences into an inequality. Ricky thinks that the mean money of snacks is greater than the mean lunch of snacks. She also thinks that the mean absolute deviations of the money of snacks is greater than the mean absolute deviation of the money of lunch. So looking at our data that I've calculated for us, I see that the mean lunch is $3.90 and the mean snack is $5.05. I also see that the mean absolute deviation is 22 cents and the mean absolute deviation of snacks is $1.64. In both cases, the snacks are greater than the lunch. However, we have to know what each part means. The mean is the balance point of the data. So this means that she must have spent more money on snacks because the mean is larger. However, the mean absolute deviation simply states the average distance of the data from the mean. So in this case, the larger the number, the more spread out the data is. So just because the snacks have the larger number doesn't necessarily mean that she spent more, and that should be reasoning. It just means that the snacks are more spread out. So we can see that if we were to use a dot plot, the top represents the money for lunch. Notice that it's all clustered together, whereas our snack data is more spread out. Aria and James recorded the number of television shows they watched each week for 5 weeks. There's their data. Which statement best compares the variability of the two data sets? It looks like we're talking in range. It looks like we're talking about the mean deviation, as well as the median. So I've listed for us the mean and the mean average deviation for both of them. We cannot look at letter A because the range does not tell us the variability of our data, how much our data varies. Similarly, the mean somewhat shows us, however, the mean average deviation is what we're really looking for because this tells us how spread out our data is. So Aria's is very much more spread out than James. James's data is more close together to the average. Let's analyze the center, spread, and shape of the data. We'll start with the center of the data collected on the right is meter jumps and the long jump distances. So the measures of center I'm giving you, the mean is 2.89, the median is 3.17, and there is no mode. But we need to know, well, which one is best when we want to look at data itself. So depending upon the type of data we have and the distribution of the data tells us what might be the better one to look at. This is continuous data because it's continually being measured. Discrete data is data that you can collect, such as how many pets do you have. It's like a final set of data. It's not measured. And then now we're down to mean or median, and it depends upon if our data is skewed or not. We see that when looking at our data up above that we have some outliers, such as 0.5 meters, that could skew our data a tish bit. So because our data is slightly skewed, the overlapping would say that the median is the better option to use when looking at the center of our data set. Let's look at measures of spread. Measures of spread, the mean absolute deviation is 0.66 meters. That means, again, that our data is pretty close together. The range is 3.54 and the interquartile range is 0.59. Let's look at the data set as a distribution. I see that the majority of my data lands between 2.5 and I would probably say between 3.99. And if I were to draw the shape of our data, I see that our data is certainly skewed to the left. Which of the following data sets have a normal distribution, meaning there's no skew to them? I would say the first one on the top left is not. Notice that it is very much skewed to the right. I would say that the bottom left is a normal distribution. Similarly, the top right is skewed right since the chunk of our data is on the left and we have some outliers on the right. And I would also say that the bottom right is normal data or evenly distributed. Create a report containing the measures of center and variability along with a dot plot to represent the data. Answer the questions from the CEO using the analyzed data. So here is some information about the number of pencils used per year. The questions that we want to contain an answer in our presentation is about how many pencils do most students use per year? Why shouldn't 60 be included in the new pack, even though 60 is one of the results in the answer? And how many pencils should be included in the new pack? And then if each pencil costs 5 cents, how much will the pencil pack cost? We need some measures of center data and variability to help us answer these questions. Here are the measures of center. The average is 24, the median is 21, the ones that happen the most are 20 and 27, and the measures of variability are for the measure mean of The mean of the average deviation is 6.68. The range is 45, and the interquartile range is 10. This is discrete data since our pencils are counted. We can't count a portion of a pencil. Here we take a look at the dot plot. I see that this is skewed right since the majority of our data is on the left-hand side. Further, we can see from the dot plot and from our measures of center, students use anywhere between 20 and 27 pencils per year. There's only one person who used 60 pencils. The range confirms this, and most people wouldn't buy an extra pencils if they didn't need to have them. Because our data is skewed and discrete, this would lead us to choose the median as the best choice for measures of central tendency, so 21. However, since the mean is only 3 pencils more and would include 6 more people in our data, in this case, the mean would be better serve the general population. If we were to have chosen the median of 21 pencils, it would cost $1.05. If you chose the mean of 24 pencils, your cost would be $1.20. Not much of a difference. Create a histogram to represent the data of the daily high temperatures for June in degrees Fahrenheit. We need to know some information before we can decide how we're going to label our data. So the maximum value is 88 by looking at the table, and the same is 55. Our range is 33. Let's create intervals between 5 or 10. I'm going to go with 5 just because the smaller the better. And I just converted my chart, and I need to identify how many of those temperatures land in each of the ranges that I chose. Since the minimum value is 5, we start with 55 to 59, 60 to 64, all the way up to 89, since our maximum value is 88, but we're still going by 5s. So I see that there are 2 values of our data in the range from 55 to 59, 3 in the range from 60 to 64, and etc. Now we can draw our chart. Notice along the left I have the frequency, along the bottom, and I have our temperature intervals that match our table. These little pieces here mean that I skipped some because we don't really care about the data that's happening to the left of here. And now we can start filling in our chart. I see that there were 2 values or 2 frequencies in the range of 55 to 59. 60 to 69 had the same amount. 70 to 74 both had 7, 80 to 84 had 6, and 85 to 89 had 2. Create a box plot to represent the data set. So these are the number of siblings living at home. We need to find the 5 number summary data to create the box plot. This will help us show the 4 equal portions of the data. So we're going to order the data from smallest to largest so that we can identify the minimum, the maximum, the median, and the quartiles. So the minimum and the maximum are 0 and 6. The median is 2. The quartile 1 is 1, and quartile 3 is 3. Well, if you think about it, 3 plus 3 is 3, divided by 3 plus 3 is 6, divided by 2 is 3, so we don't really need to put those extra steps in. We then want to start creating our chart. Putting lines, these are going to be the outlier whisker pieces, at the minimum and the maximum points. I then want to place a line at my quartile 1, my quartile 3, so that I can create a box. In the middle of our box will be our median. Further, I want to connect each one of my boxes to the outside. So even though our data is split into even groups, the box plot certainly is not proportional. So it doesn't look proportional, but the data is evenly distributed between here. Because 25% of our data lies within here, 25% of our data lies within here, 25% of our data is here, and 25% of our data is here.
Note that 50% of the middle 50% of our data lies within here, so we can identify even the interquartile range from the box plots.
Let's go backwards. Let's say we have the following box plot. Let's identify the minimum, the maximum, the median, and the two different quartiles, pulling information directly from the box plot. So we know that the two ends of the whiskers are the minimum and maximum. So the minimum is 0 and the maximum is 6. We also know that the two outside pieces that make up our box are the quartiles. So 1 and 4 are quartile 1 and quartile 3. Finally, the very middle box is the overall median. So just to recap, 25% of our data lies here, 25% of our data lies here, 25 here, and 25 here, with the majority of 50% of our data lying within the major piece of the box. And that even though our box plot is not in proportion, notice that this whisker is longer, still 25% of the data is located in each part.